Given the graph to the right, complete the table of value, should be values, and find the equation of this line. So I can see when x is -5, if I'm reading this correctly, x is -5. Whoa, y is exactly +2. So that's one of my values, right? At -5, I've got 2. Now, when is y equal to 3? Let's see, y is equal to 3. Oh, right here. There's where y is 3. And that happens when x is -2. So when x is -2, y is 3. When is y 4? Let's see. Y is 4. Well, here it is. There's y. Oh, that's fun. That's when y is 4 when x is 0. That's cool because I know the y-intercept now, don't I? Wait a minute. Is that true? Am I off there? Oh, no, I'm completely wrong. What am I talking about? No, this is my point right here. Y is 4, and that happens when x is 1. That's not my y-intercept. It must be nap time. Let's see. There we go. And then finally, if x is 4, for some reason I like starting with the domain. When x is 4, what's y? When x is 4, this function is hitting the value of 5. So I've got a 5. All right, I completed this table of values. So that's two different ways I can represent this line, right? I can represent it with this graph and also with this table. And then it says, what is the equation of this line? Well, if I look at this, I can see the slope is pretty clearly, or it's a rise of 1 and a run of 3. So I can see I've got a slope of 1/3. The y-intercept is a little problematic, right? It's in between here, but I don't think that's gonna be that difficult for us. So, let's verify the slope. I said the slope was 1/3 from the graph, but what's nice about multiple representations is I can verify that. So if I look at the change in y, right? In other words, if I take 5 minus 4, I get the number 1. And if I take right here 4 minus 1, I get the number that equals 3. So you can see my slope is the change in the y value, my y change, right, which is 1, divided by the change in x. How much does x change? And it changed by 3. So my slope is 1/3. I can see that from the table of values, and I can also see it quite nicely all over the graph, right? If I look at any two of these points that are listed, you can see again it's up 1/3. So what's that? What is that y-intercept? Well, it doesn't matter which one of these points I pick. I can pick any point um, to calculate that. And you know what? I think I'm just going to go ahead and pick the last point. I'm going to use this x value and this y value, and I'm going to go ahead and use slope-intercept form, not the point slope form. So I'll write down y equals m times x plus b. So I know for this point I have y was 5, and I know that m was 1/3, and I know that x was the number 4, and then I've got plus b. Oh, okay. So if I multiply those, that of course is 4/3. 5 equals 4/3 plus b, and I could just take away 4/3 from both sides, plus b, and I would like these to be thirds. So 15, if I multiply by 3/3, it becomes 15/3 minus 4/3. And that's going to be, whoops, not plus b, that's going to be what b is. So 15 minus 4 is 11. So I've got 11/3 is my y-intercept. So the equation of this line is y equals 1/3 times x plus 11/3 is my starting spot. on the y-intercept. Hey, let's look at that point slope thing again. So I've talked about it in one of the other videos here. So again, point slope is y minus the y value that you know equals the slope times x minus the x value that you know. And these are equivalent, right? I'm going to just plug in the information that I have, and it's going to give me the same line as the one shown above. If I do that, I would get, whoa, get back over here. I would get y minus, and I'll use the y value that I have here. I'll use the 5, and that's equal to 1/3 times, I'll go and use this x value that I know. Well, it would be x and then minus the number 4. So it doesn't quite look like it, but I guarantee if you distribute the 1/3, right, across this set of parentheses, and if you add 5 to both sides, you'll get the exact same thing. Okay, that's the last question on that page, question 10.